Hello, welcome to our first networking video in a series of videos we're going to produce in the course of our Cisco training. My name is John Ajose as usual. This is Cisco Training Enterprise, and this is our first video on Cisco networking. Now, rest assured that we have the competent knowledge to train you sufficiently well as guide you through the exams for those of you who are interested in writing the certification exams. However, we're going to wish that the materials that we sent to you, the chapter 1 of it, we want to hope that you were able to have time to go through that particular chapter, because everything that we're going to discuss, that we're going to analyze about this particular topic as we're introducing it now, is going to be based on the contents of that chapter which we sent to you all. So please, if you've not yet done a thorough read up of the first chapter that we sent to you, please endeavor to do so. Now we're going to discuss much about networking and to really understand the real concepts on which this Cisco networking is based or built on. Now, this is not just a course that we can just do a theoretical training about. Okay, at some point in time we'll need to do some practicals. Okay, and unfortunately we do not really have a full-blown network scenario where we can practicalize our knowledge or our training on. Okay, so in the absence of that, there is a wonderful software that comes to the rescue. It's called Cisco Packet Tracer. Now, this software or this IDE is what we're going to use for our demo or the practical session of our course. Okay, so everything that we're going to practicalize, we're going to demonstrate it on this software. This provides a close to real life scenario of what a real life network looks like. It's going to provide all the networking devices, all the networking gadgets that we're going to make use of and is usually made use of in the real world scenario. All those are provided for in this particular software. We're going to see how they behave. We're going to study and troubleshoot them, see the errors they usually have, the problems they have in the course of its functionality, and how as a network technician or a network administrator you can correct some of these issues and then get your network up to speed and running. Sorry about that, this guy is alright, so now let's get started with Cisco networking. Now, what is networking? Networking is just bringing it down simply. It simply means the ability to connect people, to connect devices, okay, electronic devices or gadgets together. So for example, if I have a cell phone and I'm sitting right here, it is because of networking that I'll be able to communicate with my cell phone or send a message from my cell phone and someone will be able to receive it on his or her computer. Okay, so these are tools that are there and available to help you communicate. So there are a lot of devices that are made use of in the course of networking to be able to make it possible that you can communicate with somebody who's far away from where you are. Okay, because presently we're looking at what we're starting with is the first section of this chapter 1 of the book that I sent, and that's what we'll dwell on for today: networking basics. So we want you to know some of the basic terminology, some of the basic concepts about networking that we'll oftentimes refer to or make use of in the course of our training. So it's very important that you get the basic knowledge and get the basic understanding of some of these concepts, as it will help and assist you to further understand more complicated topics that we're going to discuss in the course of this training. So first off, that is just giving you a small brief introduction of what network is all about. Okay, your ability to connect different electronic devices and gadgets together for the purpose of communication. Okay, now in the course of our training, we're going to see how this communication is possible, what makes this communication possible, some of the things that work behind the scenes to make it possible for these devices, no matter how complicated they may be, or no matter how simple or big, or they'll be able to communicate together. Now let's look at some of the network devices. Okay, some of the network devices. Now, for some of you who were able to go through the chapter 1 of this book, you may have come across something that is referred to as the OSI reference model. Now, this reference model is what Cisco uses in a lot of ways for a lot of things. Okay, we'll be able to get into that subsequently at a point where you'll be able to understand it better. But networking devices, more or less, they are broken down into the different layers of this OSI reference model. We have layers 1 to layer 7. Okay, now networking devices are categorized into each and every one of these layers. Like, for example, let's start from the end user devices. Okay, for example, on the end user devices, we have the cell phones. Today we have smartphones that can do pretty much about anything. We also have the computers, be them desktop or laptops or tabletops, whichever way, whichever model. These are end users on the network structure. These are the devices or gadgets that are the end users to facilitate, to use to actually do the communication. Okay, so computers, smartphones, IP phones, and every other thing that makes use of the internet. These are of any other form of communication. These are the tail end devices, the user end devices. Okay, now going a bit up there on the layer 2, you can have other networking devices and gadgets that makes or helps to facilitate the networking architecture behind the scene. You don't get to see how they work, you probably don't know how they work, but they are working there in the background. Take, for example, you have something called a hub. Okay, that is a networking gadget or a device that helps to connect 2 or 3 computers together. Okay, then a step ahead from the hub, you have the switch. Okay, the switch 2, it's also a networking device that helps to connect computers, to connect different networking end user devices together to be able to allow them to intercommunicate with each other, thereby being a part of a network. Okay, so from switches you also go higher. You have routers, you have servers, you have access points. There are many networking devices that you can think of, depending on how much of this you've been exposed to. Now, the good thing is that the software in which we introduced you to initially, it comes packed with many of these softwares. Okay, and for your information, in order for you to get this software, all you have to do is go to Google and type in search for Cisco Packet Tracer. Okay, you can just type download Cisco Packet Tracer. You'll get the most recent version of this software that you can install. It comes with every single networking device, or as many networking gadgets and devices that we're going to use and you're going to need in the course of working as a network administrator. So take, for instance, now going towards these end devices. Okay, these are the different end devices, and if you click on it, you get to see the different user end devices that we can make use of in the course of your programming. For instance, this is a desktop computer, this is a laptop computer, this is there are servers, there are IP phones, there are a whole lot of things. Okay, now going a step further, under switches, you can have a switch. This is a switch that I mentioned. This is not exactly what they look like, it's just a representation of it. Okay, now you get to have a bridge. This is a bit outdated, you may not see this actually anymore. Then you can move over to hubs. These are hubs, networking devices. So the software has many of the items that we're going to use to create a network. So we're going to create some complicated network with this software, troubleshoot them, see how they work, and then probably identify 1 or 2 things. But for now, we're still trying to illustrate some of the basics that will help you understand other complicated concepts as we move over. Now, if you look at this book, there's something called a LAN network. Okay, now this takes us to the second thing I want to discuss: types of network. Okay, types of network. Now, these types are categorized based on their size, based on the range of coverage. For example, a LAN network is the simplest or the basic. That's a group of computers such as this. As you can see, 2 or 3 or 4 computers connected together to one hub, That makes up a LAN network, local area network. So they are all local, they are all together or not too far away from each other. From LAN network, you also get to have a WAN network, a wide area network. Okay, that's usually WAN, WAN network, wide area network. Take note, LAN stands for local area network. Then you also have MAN, MAN. Okay, MAN has the acronym for that means Metropolitan Area Network. So you get to appreciate the size of these networks by virtue of their names. Then there's also something called VLAN, that's virtual LAN. These are end users that are not really situated together either in the same building or in the same structure. They could be scattered over a long distance, but virtually they are all connected together. So basically these are some of the different types of network based on their component, based on their structure, based on their physical location, and so many other considerations. Okay, so each and every one of these different types of networks, we're going to sample them. We're going to see how they behave, their advantages, their disadvantages, and where which is applicable, where is which of them used, things like that. So in order for you to have a full-blown working network in which as an administrator you're going to work on, it means you first of all there has to be some end user devices. Okay, by end user devices I mean computers, things that eventually people use to communicate. Okay, take for example this is a smart device. It's not really what they look like lately, but that's the best we could have. So let me delete some of this out of here. Yep, delete some of these stuffs here. So you're just going to be watching how I'm using this software IDE, and that will give you an idea as to how these things are being used. Okay, so let me select one of the switches. We'll discuss more about switch and their different models subsequently. This particular section has to do with different means of connecting each of these devices. We'll still look at them one at a time subsequently. Now if you see this button, if you hover over this button, you can see under here there's automatically choose connection type. So once you click on this one will select the best form of connection, okay, that is going to be applicable. We're going to discuss that later. So I just want to sample to create a little bit of a WAN, what looks like a WAN network. Okay, so these are currently three user devices connected to this switch. So this is a simple LAN network that we've created. Now what I wanted to illustrate with this is the fact that for you to have a network that you can troubleshoot, okay, let's take it a step further. Let's add a router. Let's add a router to the mix and then connect the router to this. Okay, so for you to have a full-blown network, first thing you're gonna need some end user devices. They could be computers, it could be laptops, it could be IP phones, and the rest of them. Okay, I think I had a typical this is an IP phone. So you connect that to your switch and you'll be able to. So this is typical, simple but somehow complicated network where you have different types of end user devices, okay, that are connected to. You can also even connect, you can take it a step further. The end user devices here, they are printers that you can even connect. Okay, so you can see there are end user devices. There are devices that operate on a slightly higher level. Okay, for example, this is the switch. The switch does not belong to the same layer as the end user devices because this one helps to connect this guy to this guy to this guy to this guy, whereas this other one is the grandfather of them all and has its own unique role and responsibility in the network structure. So you're gonna have to need a means of connection as well. The computers will need to be connected some way to the server, either through a LAN cable or through wireless connection. So for you to have a full-blown network that you're going to have to troubleshoot or work on, you're going to have to need user end devices such as this guy. You're going to need some higher end devices such as this guy or this other guy. And then you're going to have to need a means of connection. We're going to discuss many of these other things subsequently. Now, aside from having all these things, you also need a means through which these guys are going to identify and recognize each other. They're not human, so they don't think on their own. So they're gonna need something that will coordinate their activities and help them recognize who is sending what to who. And there is where protocols come in. Okay, so you're gonna need some form of protocols in order for you to be able to run a particular network. These are some of the subcomponent things that you're going to need in order for you to be able to work with a network. Now, for those of you who were able to read this particular material, you see this illustration here that asks the question, how is it possible that, okay, let's say this is Bob and then this is Sally. Both of them are on the same network and they want to communicate with each other. Let's start the real practicals now. How is it that Bob sends an email to Sally? Okay, now in order for us to be able to really understand this concept of transfer of information or communication between two different end user devices, I made use of an analogy. By an analogy, what I mean there is something that will help us better really understand these concepts. Let's refer to a network as a neighborhood where people are living. Okay, now in a neighborhood you have, let's say, house A1, house A2, house A3, let's say all the way to house A100. That is a huge big neighborhood. Then over the other neighborhood you have house B1, B2, B3, B down till 100. So the neighborhood where you have houses labeled A, that is one single network. Let's look at it that way. Then the neighborhood where you have houses labeled B, that is a different network entirely. So let's start with people in the same neighborhood. Let's say I'm living in house A1 and I want to communicate with Sally who is house A3. We're in the same neighborhood, we're not far away from each other, but since these guys are not humans, they're going to need something to help them locate one another, and that's where protocols come in. Now, just like I made reference to the OSI model, at different layers of the OSI model there are different protocols that work to help these end users communicate and know what to do at every point in time. Now, Bob here will send out a message in order to be able to communicate with Sally. Bob does not know who is Sally. And take note, when you power on your system for the very first time and you're entering into any network, it's more like you are moving into a new neighborhood. Just have that analogy. Just powering in your computer or you're connecting to a network as an end user is similar to moving into a new neighborhood. So at that point in time, you do not know anybody and nobody knows you. So there's going to be a process where you're going to find or try to get to know your neighbors, try to get to find out who is who, and then have a record of all your neighbors. So that is what is being demonstrated here. Now, what happens there is that when Bob connects to this network and then Sally is connected to this network and both of them are connected, they don't know each other and they cannot recognize each other. So in order for, okay, let's say Bob is given a message to deliver to Sally in that neighborhood and Bob does not know who Sally is. So what Bob will do, Bob will send a broadcast message or broadcast information. Let's say each neighborhood has a huge speaker or an in-house speaker where everyone can send a broadcast that everyone in that neighborhood from A1 to A100 will get that information. So Bob here will now broadcast a message. Hi, I am 192.168.03, and by the way, these are IP addresses. Okay, IP addresses are the identifying, it's a means of identification within the network. So it's more like Bob here now, who is living in house A1, wants to send a message to Sally, who is living in house A5. Okay, now take note, Bob knows that he's sending a message to Sally, but Bob does not know which house Sally lives in. that's a similar illustration I'm going to use to explain this. So in order for Bob to send a message to Sally, which he does not know where Sally is living, Bob will have to send a broadcast message. Hi there, a recorded message, and it plays on everybody's house from A1 to A100. Hi there, my name is Bob and I have a message for Sally. Please, where is Sally's address? That is what Bob is looking for. Sally's MAC address. Now these are addresses that are hard-coded to each networking device, the network card of each networking device. If you look at this, let's take this for instance. Let's say, okay, good. Now look at this particular user now, this laptop. This is its MAC address. It's unique, it never changes, and it's different for each and every different networking device, be their smartphones, be their computers, be their connected printers. Each and every networking device have a MAC address, and this comes pre-configured on its network card. That means the manufacturers are the ones who get to set this automatically. So this is the terminal end means of identification that never changes. So when Bob here is making an announcement, a broadcast announcement for Sally's address, it's basically asking for Sally's MAC address, because he already knows that he is looking for Sally. And take note, in this case, for computers, since they don't make use of each other's name or human names like Bob and Sally, what they make use of in place of names are IP addresses, which, as is also the case, are also unique to each other. Just like Bob is unique for him, Sally is unique for her. So 192, so assuming this IP address is for Bob, and scrolling down, and then Sally has a different IP address. So with the IP addresses, Bob is going to announce, hi, my name is 192.683.0.3, which is Bob, and I have a message for Sally, who could be 192.168.0.5. Please, Sally, can you send me your house address so I can come deliver the message to you? So that is what is referred to as here in the query. This is a network analyzer viewing this. So this is the source, this is the destination, which is a broadcast address. This is a protocol name query, and is looking for Sally. This is a typical illustration, but in essence, this is what it's going to look like. This is Bob's, this is the source. This is Bob's IP address, this is Bob's MAC address, and he's sending a broadcast information to everybody who is there on that network. So as Bob does that, others in the neighborhood will get the message. Magdalene will get the message living in the same neighborhood, let's say A10. Peter will get the same message living in the neighborhood, let's say A5. Others will get the same message. So when they get the same message, since they are not Sally, they will not respond to the message. They will drop the message and cancel it or throw it away, since it doesn't affect them. But when Sally gets the message, Sally gets to know that this message, broadcast message, is a message that is looking for her. Okay, so when Sally gets the message, Sally now responds in the same way as Bob does. Okay, and that what controls this broadcast message is the ARP. That's what is called ARP protocol at that particular layer. We'll come to it sooner or later. I'm trying to just use an analogy that will help you really appreciate what all this story is really all about. Okay, so this is Sally's response. Hi, I am 192.038.0.3, which is Sally. This is I'm sending a message back to Bob, who is 0.2, who was looking for me. That is the ARP protocol. And Bob, this is my address, 000B. This is my house address. So Bob now gets this message and then stores it in his own records, that this is Max and Sally's address. So any other time Bob has a message that wants to deliver to Sally, Bob will just make use of this address and not need to send out the broadcast message anymore. I know this may be a little bit hazy, but use that concept as you're reading it, go through it, you will be able to understand it a bit better. and I could now be able to offer more explanations where you do not understand. Now, given that concept, you'll probably realize that the more houses there are in a neighborhood, then the longer it will take for messages to reach each one, especially when you're trying to broadcast messages like that. You're gonna need more, how would I put it, bandwidth, more speakers, more locations. A whole lot of resources are going to be the more the houses, the more the resources needed for you to send out a message. So that is typically what we call, we could refer to as a collision domain. Okay, now the more the network, the larger the network. By network we mean the larger the number of end users in a particular network. Let's say we have 500 laptops, 800 IP phones, and so many other networking devices. Now the network is going to be so big that it's going to be so congested. As you can see here, there's going to be LAN traffic congestion. Okay, there's going to be a whole lot of congestion. It's going to be difficult for Sally to look for someone who he or she does not know. The process is going to be cumbersome, and usually there's something called, and okay, before I get into that, for example, this statement says that a switch can replace a hub and breaks up collision domains. Now, by collision domains, here is one thing. Depending on the kind of layer device you're using to connect all these user end devices, your network could be really messed up because of how these guys perform their work. These guys provide a channel through which this communicates. Now, a switch is better than a hub. This is a hub. A switch is better than a hub when it comes to connecting together end user devices. Why do I say so? A switch provides you what appears to be like a double lane traffic lane, or how would I put it? A double lane traffic road, where you have a large size of road only for cars who are going in one direction, and a large size of road only for cars going in the opposite direction. So a car that is going in a direction will not move over to the other lane where cars are coming. I don't know if you understand the concept properly. So that is what this provides you, and you can understand that for those of you who drive, you know that when you have a 2-lane road, you can move faster than when you have a single lane road. So a hub provides a single lane road that makes it difficult for people to move. So if there's going to be a likeliness of traffic congestion when you're using a hub, and when you have a whole lot of traffic neighbors in the traffic. So we're going to stop here, and then we'll continue from there from our next video. So